All right, welcome back to another fun-filled, action-packed, non-flipped Algebra 2 classroom with me, Coach Gu. Today, we're going to add on to our notes from last time because there's not enough to where we need a whole nother notes paper, okay? So, on the back of your paper, but before we start, I'm not going to just tell you the answer or how we do today's topic, but I want you guys rather to try to figure it out on your own. So, today's topic in general is going to be rational exponents. Very quick concept, not that much, okay? Just rational exponents. What that means is when your exponents, you see right here? You see the exponents? They're fractions. You see that? Yeah. X to the 1/2, x to the 1/4, all that. We've been working with radicals and roots. So, what I want you to do is, with the people around you, discuss. There's a rule. When you have fraction exponents, there's a rule. Okay, and I want you to discuss with the people around you what you think that rule is. And you can see a pattern with all these examples right here. All right? You can see a pattern here, and I want you guys to discuss with the people around you. So take some time for that, and then we will see what your guys' answers are. All right, so as we just figured out, Trey's told us, but the numerator on the exponent is going to be our power on the inside. Notice, on x to the 1/2, x is to the first power. That's why there's nothing there, right? Same thing over here. And then down here you can see, especially when it's x to the 4/3, the 4, the numerator, that's the power on the inside, x to the 4th. You see that? And then Trey said that the denominator, the bottom number of the fraction, is going to be our index. Remember, the index is a small number on the radical. All right, so notice that happens in all of these examples, okay? Bless you. So however you want to write that down, doesn't matter. Make that note for yourself. These are notes that you're taking for yourself. So however you want to tell yourself that, write that down in your notes. All right, so now we're going to do examples. We're going to do 4 examples, so make sure you leave room for yourself. So first of all, let's write the instructions down for the examples so that way you can see what the questions are actually asking depending on the different instructions. So the instructions for these 2 examples is just going to be simplify. So example 1, we're going to simplify 64 to the 1/2. Notice the instructions just say simplify. It doesn't say give all the real roots. It just says simplify. So what kind of answer should you be giving? So 64. If you don't know what the instructions mean, let's work through and then we'll see at the end. So, we have a problem like this. We have to simplify 64 to the 1/2. So first thing I want to do is rewrite this using a radical. So rewriting it as a root. So how can I rewrite it? Square root of 64, that's right. The index is the denominator, that's a 2. So we're going square root, and the power is 1. So we just go 64 to the 1, which is just 64 on the inside. So that's what this question is actually asking. Simplify the square root of 64.
8.
And your answer is 8. Now, why did you not say plus or minus 8? That's where the instructions come into play. It didn't ask for all real roots. It just says simplify, right? And that's when we know that that sign just means the positive version. So this is your answer, 8. Very good. Our second example then is going to be the negative 1,000 to the 1/3 power. Negative 1,000 to the 1/3 power. So first we want to rewrite that into a root. So how can we rewrite that? It's going to be cubed, the cube root. Right, the index is the denominator, 3, and then of negative 1,000 to the 1, but we don't need to write it to the 1, right? It's the same thing. So that's what we're looking for. We're looking for the cube root of negative 1,000. And what this is asking is, what is the number that is going to multiply by itself 3 times to give us negative 1,000? And you said? Negative 10. That is the number that fits this equation. So the answer is negative 10. And that's our first 2 examples. Put the pausing. All right, now onto a few more. We got 2 more examples, but these ones are a little more complicated. Pay attention to these instructions now. The instructions will be simplify and then assume all variables are positive numbers. Does anybody have an idea of why the instructions would tell you to assume that all variables are positive numbers? For example, if I have an example like this, 24, x to the 6, y to the 10, all to the 1/2, why would the instructions tell me that assume all variables are positive numbers? How would that change what our answer is going to be when we write our answer? Does anybody have an idea? Wait, what? What about that? So we would use the absolute value? What is the purpose of putting the absolute value bars in our answer before? To make it positive. The instructions on this one tell us that all the variables are going to be positive. So we don't need to use absolute value bars. Very good. So that's what this is telling you. By assuming that all variables are positive numbers, you don't need to use absolute value bars because it's telling you that it's going to be positive. All right? So there's a difference in instruction. Okay? So make sure you understand that. Because when you're doing quizzes, tests, right, instructions matter. All right, so first of all, we want to rewrite this using a radical. So how can I rewrite this expression? Square root of? That's right, we're going to use the square root of 24x to the 6, y to the 10. The index is 2, so we use the square root. All right? So we want to write an answer. Now remember, on this case, we might have some terms on the inside left over, remaining inside the radical, and some terms on the outside of the radical, right? Now the first term we're working with here is 24. But is 24 a perfect square? No, it is not. So, if you can't take the square root of 24 easily, because some people know how to do this, some people do not, there is a tool, a method that you can use to always find out what's going to be on the outside of the radical, what's going to be left on the inside. And that tool is upside down division. So we take 24. I'm going to show you how to do this method, okay? We take 24, and we're going to divide it by the smallest number that you can divide it by that's not 1. 2. 2 is the smallest number you can divide 24 by that's not 1. You have to divide it by prime numbers, okay? So if I divide 24 by 2, what's left? 12. What can I divide 12 by? 2. What's left? What can I divide 6 by? 2. And then 3 is left, and what can you divide 3 by? 3, and what's left after that? 1. When you get to 1, you're done. So 1 and done. All right, now what was the point of that? This shows you all the factors that multiply together, the prime factorization of 24. All right, and we're going to use this to see what comes out of our root and what stays on the inside. So what is the index on our root? You need to identify that. The index is 2, right? It's a square root. Invisible 2 right here. And that's going to tell you how big your groups are. As in, look at these numbers here. We're going to look for groups of 2 or pairs. Do you see any pairs of numbers here? Yes. What? 1 pair of 2s, right? And so, when we pair them off like that, the number that is inside our group, what is the number right there? 2. That number is going to be on the outside. Hang on, so we're about to get to that. And then the number of groups that we have, the number of pairs in this case, how many pairs do we have? 1. That's the power that goes on to the 2. So we go 2 to the first. So as you're asking, if we had 2 pairs of 2s, it would be 2 to the second power. That's right. If you had different types of numbers, then you'd multiply them together. But in this case, you just have the 2s. All right, and then what numbers do we not pair off? The 2 and the 3. So we're going to multiply those numbers together, and that is remaining on the inside. So what's that going to be? So we got a 6 left over on the inside. See that? So notice this is the exact same method. Remember, before we kind of saw something like this. Look, square root of 24. What makes square root of 24? Square root of 4 times square root of 6. And then what's the square root of 4? 2 square roots of 6. See how you get the same answer? But one way, you don't have to be as intuitive as the 4 times 6. You see, this is like guaranteed to get it to you. The other one, what if I said like 3 times 8? That wouldn't actually give you the right thing. See? All right, so we took care of the 24. That's this. Now, we got to take care of the x to the 6. So what will I do with x to the 6th? Divide what by 2 exactly? The 6, right. We're going to divide the 6, which is the power on the x, divided by 2, which is the index, right? And how many times does 2 go into 6? 3. And what was the point of that? What does that tell us? X to the 3rd power where? On the inside or outside? Where? Outside, right. The whole point of dividing right there is to show us what's going to be on the outside. X to the 3rd is going to be on the outside. Was there any remainder when we divided 6 by 2? So there's no remaining x's on the inside. So that's it right there. That takes care of the x's. Now we got to go to the y's. What about the y's? 10 divided by 2, which is? So y to the 5th power on the outside. That's right. Any remainder? So there's no y's left on the inside of the radical. And so this right here would be your answer. You don't need to write the 1 above the 2 because, right, that doesn't change it. That would be your answer right here. We don't need to use absolute values because the instructions tell us the variables are positives, right? And so that is example number 1 of this type of problem. Is anybody still writing this? All right, so on to our last example then. We're going to use the same instructions, okay? Simplify, assume all variables are positive numbers. So this example is going to be 48 x to the 15th, y to the 11th, to the 1/3 power. All right, so first thing we want to do is rewrite this using an index, a root, radical. Wait, let me make sure it's recording actually so I don't, okay, there we go. All right, so how can I rewrite this expression using a radical? Cube root. How did you know it's cube root?
Because the denominator is 3.
The denominator of the exponent is 3. Good. Of?
48 x to the 15th and y to the 11th.
That's right. There you go. Okay, so now we're going to see what the answer is. So some of our terms are going to be on the outside of the cube root, and some of our terms will be on the inside. So I'm just drawing that there. All right, so 48, is that a perfect cube? No. So, and can you guys figure out the factorization of that instantly? Probably not. So we're going to use upside down division.
How is it 2 groups of 2?
Hang on. So let's get this down. So 48, and what are we going to divide 48 by? 2. Which leaves me with? What are we going to divide 24 by? 2. Which leaves you with? What do we divide 12 by?
3. No, 4. 2.
2.
Yeah.
Go with the smallest number possible. Any even number is always going to be 2, right? All right, so when you divide 12 by 2, what's left? 6. What should you divide 6 by? 2. You have 3 left. Now what do you divide 3 by? 3. And then you hit 1 and you're done, right? Okay, so this is the factorization. 2 times 2 times 2 times 2 times 3 of 48. All right, now, this is why it's important to identify the index. Right here, we're not looking for pairs. What are we looking for? What is your index on this problem? 3. So instead of looking for pairs, we're going to look for triples. That's right. That tells us how big our groups are, remember? So, what triples do you see here? One group of 2s, right? Right here. So, what is the number that's going to be on the outside of our cube roots? A 2. And what's the power on that 2 going to be? 1. Why did you say 1? There's only one group, right? Only one grouping. So 2 to the first. That's right. And what did we not group off? 2 and 3, which multiply together to give you. And where does that 6 go? On the inside, right? Because it didn't get to group. So that takes care of the cube root of 48. So then we move on to the x term. X to the 15th. What do we do with that? 15 divided by 3. Why 3? That's the index. And what is that? 5. Any remainder? No. So what does that 5 tell me? Bless you. Bless you. What's on the outside? X to the 5th. X to a power of 5. Right. So there's no remainder, so there's no x's remaining on the inside. So then lastly, we got to do the y term. Y to the 11th. So what do we do with the 11? Divide by 3. And how many times does 3 go into 11? 3 times. And that would leave a remainder of what? 2. So what does this 3 tell us? Y to the power of 3 on the outside. And then Omar, what'd you say? You're not Omar. All right, inside y to the power of 2. That's right. The remainder is the power on the inside. That's remaining on the inside. Right. And that's your answer. Boom. So that is it. You don't need to write the power of 1, because it doesn't change anything. And that's going to be it for the notes for today. So until next time. See you then. Peace.